Chapter 5.5, Similar Figures. For this lesson, we are going to be talking about how to use proportions to find missing lengths of similar figures. So what is a similar figure or similar polygon? So a polygon is a closed plane figure formed by 3 or more line segments that don't cross. Basically, your basic squares, triangles, rectangles, etc., those are your polygons. But what does similar mean? Similar means that the shapes are the same shape but different sizes, their lengths form equivalent ratios, and the corresponding angles have the same measure. So if you look on page 207 in your book, you will see two triangles, triangle ABC and triangle FGH. I have redrawn them here relatively neatly. However, I did not put in the corresponding angles. You will note that angle A and angle F are both 83 degrees. Angle B and angle G are both 53 degrees. And angle C and angle H are both 44 degrees. So the triangles have the same degree, but the lengths need to form equivalent ratios. So how do I know if they have equivalent ratios? Or how do I find out what's missing? So let's take a look at example 1. So this means triangle ACT, or this triangle here, ACT, is similar, that's what this wavy line means, to triangle ODG. Notice that the letters are in the same order, moving the same way around the triangle. So ACT, ODG. I even color-coded it, showing that angles A and O are the same, angles T and G are the same. Excuse me. Oh, excuse me. And angles C and D are also the same. So I'm going to use that in order to show that, or to find X. I don't know the length of segment AC. So here in the numerator of my ratios, I'm going to have the same triangle, triangle ACT. The denominator is going to be the other triangle, the one I'm comparing it to, triangle ODG. And I'm going to compare the same line segments. So here I have AC comparing to OD or DO. The letters don't have to be in the same order necessarily as long as it's the same segment. Those two ratios, this triangle to this one, should equal A to T or AT to OG. So let's use some numbers here. So AC has a value of X. OD has a value of 50. This ratio should be equal to AT, which is 24, to OG, which is 30. I want to know, what does X equal? So I'm going to use cross products in order to find out. So 30X equals 50 times 24. What's 50 times 24? I don't know, I'm not going to do that math in my head. 50 times 24 is 1200. Divide both sides by 30. And X equals 40. So the length of of side AC is 40 centimeters. Now, the other option is that I can reduce 24/30ths first. So if I have x over 50 equals 24/30ths, if I divide both by 6, it equals 4/5. Well, using mental math, how do I go from 5 to 10 or 5 to 50? I multiply times 10. So I'm going to multiply times 10, and x equals 40. Both methods are perfectly valid. Use the one that works best for you. Okay, example 2. Why on earth do I need to know how to do this? So here I have a flagpole. Yes, this is my little flag, don't laugh. I have a flagpole. I have no idea how tall that flagpole is. But the shadow that it makes is 15 feet long. Here I have a man who is 6 feet tall, and his shadow is 4.5 feet long. So how can I use this information to figure out how tall is the flagpole? So my two triangles, I'm going to have my flagpole here in my numerator and my man in my denominator. So x height of the flagpole, 6 feet for the man. The shadow is 15 feet of the flagpole, and the shadow of the man is 4.5 feet. So my ratio is x to 6 equals 15 to 4.5. I cross cancel or cross multiply. 4.5x equals 16 times 5, 90. 6 times 15, 90. Divide by 4.5. And x equals 20 feet. So my flagpole is 20 feet high. Okay, that's it. Quick checks and check your understandings, and we'll go over this the next time I see you.